Kia ora, Stefano. Okay, so for question 3 of Complex Numbers 2017 from NCEA. Okay, if u equals p cubed cis pi over 3 and v equals p cis pi over 8, write u over v in polar form. Okay, so all we have to do here is, if we want to do 1 divided by the other, these p cubed, all you do is you actually divide algebraically for the modulus, but then when you're dealing with the argument, you just minus. So I'm going to multiply that first one by 8 over 8, so that becomes 8 pi over 24, and then the second one I'm going to multiply by 3 over 3, so it becomes 3 pi over 24. Convenient. I'm going to chuck that in brackets because who knows, someone might get it wrong, misinterpret. So that becomes p squared, yes, okay, p squared, whoopsies, cis, and then 8 minus 3 is 5, so it's 5 pi over 24. Okay, cool, and that's already in polar form. Okay, so solve the equation x squared minus 6x plus 14 equals 0. Give your solution in the form a plus or minus root pi, where a and b are rational numbers. Shucks, got to get these papers under control. Okay, so this form here is the form that completing the square comes out as. So let's just do a quick little recap on how to complete the square. So all we do is we get this number here, and we divide it by 2 and then square it, and so that gets us 9. So instead of that being a 14, we want it to be a 9. So I'm going to go like this: x squared minus 6x plus 9 equals, and I'm going to shove everything else on the other side, so negative 5. Right, and because that's already a completed square, that's x minus 3 all squared equals negative 5. I wonder if I should explain that for you guys. Yeah, I'm going to draw a quick picture of what I just did then. What's important when you're completing the square? I draw a square, that's how I remember it. So we've got this minus 6x, and we need to find, so minus 6x, so we're going to have x squared here, so it's x, and this one's because it's a minus, we're going to minus something here, and x, and it's going to be a negative here. Now 6 over 2 is 3, so that becomes x minus 3, so that gives you a negative 3x here, and that's minus 3 as well, which gives you a negative 3x here. But then negative 3 times negative 3 gets you 9, and so it completes the square. So the area of this is x squared minus 6x plus 9, but the area is also x minus 3 all squared. So that's what we're doing. Okay, so now let's just unpack that. X minus 3 equals, oh yeah, I'm doing that right, square root of negative 5. Ha! Imaginary number. So then x equals 3 plus, oh shucks, nearly made a mistake, plus or minus square root, and I'm going to pull the I out because that's the form they want it in, and there we go, perfect, that is in the form. Maybe we'd have to mention that a and b are rational numbers, but not this time. Okay. 3x cubed plus 8x squared minus 2x plus 11 all over x plus 2 equals 3x plus ax plus b plus c over x plus 2, where a, b, and c are integers. Find the values of a, b, and c. So what's going to happen is we're going to shove all of the integers on the left side. Ooh, after I've multiplied by x plus 2? I think that has to be done, yeah. So I'm going to multiply everything by x. My flatmate's looking at me quizzically. I'm recording a video. Huh? I'm making a video.
Oh, no, the dog's barking at me. I'm like, what?
Oh, yeah, because Finn's barking. You know Hayden. Okay, so I'm going to multiply both sides by x plus 2 first. Well, it's going to make a bit of a mess on my page, but that's why we do maths. X squared minus 2x. A really important thing with maths is being able to, like, copy stuff down well. Which is a bit sad, because many people are not good at that. Plus, oof, man, yeah, this is a bit nasty. Hey, at least they did this beautiful thing with C here, where it's c over x plus 2, and then you multiply by x plus 2, which means c stays the same, which means we have a little bit of space to put it all in. Nice. Okay, so everything that's not got a letter involved, I'm going to shove over to the left-hand side. So that's 3x cubed. So that's going to make that 6x cubed. Oof, no it's not. Dang it. Nearly made a mistake. Yes, I'll throw the ball for you, Finn. Yeah, so what happens there is 3x squared gets multiplied by x to get 3x cubed, then we shove it over and that cancels that out. Then we get 3x squared plus 2, which gets us 6x squared, and then 8 minus 6 is 2, so that becomes 2x squared minus 2x plus 11, so that's ax squared plus bx plus c. Nice, that's all ready to go. Okay, now let's deal with this. Ax squared plus 2a, and then I'm going to actually do something sneaky here, plus b x. Now that was a little bit sneaky, but I don't want to do too much working. I'm just going to show you what I did. I know that this ax times 2 is 2ax, but I also know that this b has an x attached to it, and I want to just find my b value, or like the second part of my quadratic form, like all attached to x. So I'm just sort of doing two steps at once. So that's that done, that done, that done. And then we get plus 2b plus c. The reason I've put these in brackets is now you can see that I've matched up. So a is matched up to that 2. 2a plus b is matched up to that negative 2. 2b plus c is matched up to that positive 11. So now I've got some simultaneous equations ready to go. So I know that a equals 2, which is a great start. I also know that 2a, actually why am I writing it as a? I already know what a is. I know that 2a, which is 2, plus b equals negative 2. So that's ready to be solved. So b equals negative 6. Ooh, did someone unplug my computer? I just got a bit of delay. Okay, so then now we know what b is. This other one should be easy as well. 2 negative 6 plus c equals 11. So do you see where I'm grabbing these things? Negative 12 goes over the next 23. C equals 23. That's all solved. So what I'm doing is, you can see here, everything attached to an x squared on this side is equivalent to what's attached to an x squared on that side. So that's why I made that a equals 2. Everything here, negative 2 is the same as this 2a plus b. And here, that plus 11 is the same value of whatever that is there. Because that's in the quadratic formula, which would be lowercase ax squared plus lowercase bx plus c, right? Because red is all my lowercase a stuff, blue is all my lowercase b stuff, and green is all my lowercase c stuff. So they are equivalent. So that's how I can form these simultaneous equations to solve for these letters. Right done. D. Solve the equation, blah, 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 writing it like that. Okay, I'll multiply by x first because we don't want something like that on the denominator. 8 plus x equals square root 3x. I love having this nib on my square root because then you know that the x isn't being rooted, which is very handy to know. I'm going to do all my x's together. Oof. Oh, sick, thank you. Not liking how this is looking at all. I'm going to leave the 8 over here. Root 3x. I'm putting my x's together so I can do that classic factorize trick. So that's a good way. If you've got two separate x's being manipulated differently, factorization is a great way to get that x by itself, to isolate it. So that makes it root 3 minus 1. And I don't have to break up that surd and work out some dirty decimal. So then I get 8 over root 3 minus 1 equals x. But that's not the form they wanted in. So we're going to have to bring this surd up off the denominator. So to do that, we are going to multiply by I guess we'll do root 3 plus 1. Let's try that. It's looking a bit ugly, but I'm going to chuck it over here. 8 over root 3 minus 1 multiplied by root 3 plus 1 over root 3 plus 1 equals, this is an expression for x, by the way, 8 root 3 plus 8 over root 3 times root 3 is 3. These things cancel out. Negative 1 times positive 1 makes minus 1, so that's over 2. 8 over 2 is going to be 8 over 2 is, so it's going to be 4, putting it in their form now, plus 4 root 3. Nice. Now that is in the form that they so desired. Beautiful. This conjugate tip is a great way. I don't know if it's called a conjugate with surds. I'm pretty sure it is. I'm not very good with English again. Great excuse. The reason that this works, because if you have a plus b, a minus b, if you look at how that expands, you get that a squared plus, did I do something wrong? Let's just pretend I was doing something. ba minus ba minus b squared. So these cancel out, and conveniently, this, if there's any square root there or a square root there, these will get squared, so this will destroy square roots, and then these will cancel. So it's just a great way to get rid of square roots. And you saw on the bottom there that it made it into a 2, which is just nice, and it sort of brings the surd up. Okay, final question of the whole paper. Z is a complex number such that Z equals A plus BI over A minus BI, where A and B are real numbers. Finn, be careful please, man. Prove that Z squared plus 1 over 2Z equals A squared minus B squared over A squared plus B squared. So, what we're going to do here is, in NCEA they like us to work with, start with one side. So LHS just stands for the left hand side, which means we're dealing with this bit here. And we're going to deal with that until we get, so that's, LHS, until we get our right hand side. Now, what I like to do is I like to sort of, let's just have a go at it, left hand side. So let's just write out Z fully. So it's going to be A plus BI over A minus BI. And then over here it's squared, so we're going to do it again. A plus BI over A minus BI. Now, there's going to be a plus 1 here, but we're going to have a think about that. What we're going to make. 1 to me is anything but 1. 1 to me, oh wait, where's my face? I'm probably drawing under it. 1 to me is A over A. Or maybe A is a bad example in this case. 1 to me is alpha over alpha. It's whatever I want over itself. Right, so we're going to have to find something cool to make 1. Let's just do 2Z first. 2, that looks too much like a Z, sorry, I have to go back. 2 A plus BI over A minus BI. Okay. I'm getting a bit messy for some reason. Okay, now, what I see when I look at this is I see a common denominator. See this A minus BI and this A minus BI. I want to get rid of that. So in order to do that, my alpha today is going to have to be that A minus BI over A minus BI. So that's going to cancel. Let's do red for cancellation. That is going to cancel with that. Now, does it cancel with this? No, it doesn't. It doesn't cancel with that because that is being multiplied here. So you only need to cancel one thing. Let's look at an example. For example, if I was saying like half times half over half. Oh, no, this is a complicated example. That is 1 over 4 over a half. I can multiply the top and the bottom by 2, which means that that half remains on the top, but then the 1's left over on the bottom. It's not a great example. But if I was to cancel both of these, I would just get 1 times 1 over 1, so that'd be 1, which is not this, which is not a half. So that just is like a... When I'm in an exam and I come to having to work something like that out, I sometimes just do like a little basic example with like basic letters or numbers to get a grasp on what I need to do. Whereas this one's being added, so this one we do have to do a little bit of cancellation there. Okay, what else am I going to do to prep this for simplification? I'm going to bring this 2 up because I just want a plus b on the bottom. How do we get a plus b? So I'm going to have a look at that. Where does a plus b come from? So I'm sort of putting a focus on this because I want my base to end up with just that. And then I'll just deal with the top on its own. It'll make things easier. So to get a plus b, what do? So right now I've got a plus bi on the bottom. What do I need to multiply that by to get that a plus b squared? Is it another one of these? Let's have a look. So that gets us a squared plus 2ab 2abi minus b squared. Nah, that's not helpful. Let's have another look. What about a plus bi, and then we'll do the conjugate. How does the conjugate work? That gets us a squared. That same thing happens that I just explained before, that those minuses cancel each other out. So bi times negative bi, that's going to get us plus b squared. Haha! So that's how we're going to get our a squared plus b squared on the base. So see how I just sort of did like a tinker over here? Let's have a look at some figures to work out a strategy. So what I'm going to need to do is I'm going to need to multiply by this, obviously, a minus bi. And I'm going to need to get rid of this 2. This 2 is useless. So I'm going to bring that 2 up. So that means I'm going to have... Ooh! You know, I just realized we've got an a minus bi up here already. So if we just divide that... So what I'm going to do is I'm going to multiply the top by a minus bi and the bottom by a minus bi. So that's going to get me a plus bi in the first one. And I'm going to multiply... Let's just do this. Let's say what I'm doing. Multiply by a minus bi. And that's going to cancel out this. So I'm going to be left with a plus bi. And then I'm going to have to multiply this side by my a minus bi as well. A minus bi. A minus bi. And then I'm bringing that 2 up. So this is all going to be divided by 2 on the top of my overall fraction. Maybe I'll put them in square brackets so it's a little bit easier to see what's happening. And then on the base, I'm left with my, because we just worked out what that does before. We'll do it slowly, just for the sake of the marker. So we're going to have that a plus bi. We're going to have that a minus bi on the base. Nice. Okay. So let's go through and do this now. So on the top, we're going to get a squared. We're going to get a plus 2abi. And we're going to get a minus b squared. So that's that first square. Let's have we got the second square. Second square is going to get us an a squared. It's going to get us a minus 2abi. Convenient. And then we're going to have negative, negative makes a positive, and then that goes to a negative because our i's. So that's going to be minus b squared. That's all over 2. Keep that in these. And that's all over. We did that over here. Why work it out twice? We may as well work it out twice. If you've got time, then work it out twice by all means. Okay, cool. So we've got the base looking good. So now let's just go through and see what cancels out. What was I using for cancel? Red. So that, see how we got a minus and a plus there? Nice. So that's going to become, well, we got 2 of them, so that's 2a squareds. So that becomes 2a squareds. And we've got minus 2b squareds. That's all over 2. And then over, oh, I'll be happy with that. I'm just going to make it like that. Nice. A squared plus b squared. Sweet, and then easy peasy, those 2's all just cancel. Shing, shang, shong. And that gets me a. Oh, how pretty. A squared minus b squared over a squared plus b squared. Let's have a look. That is our right-hand side. So we can write equals R, H, S, and then we just draw the best box we can. That means proved. There's like another cool way to do it. You do like a Y going like that, and where do you do that thing? I can't remember where you do the other bit. It's like a Y with a... I actually don't know how to write that. I'm just going to stick with the box. Come on. Come on. This means proved. Proved. Sick. Okay, cool. Well, that's it. That's the 2017 complex numbers paper. If you could leave a comment on what you want me to change for the next time I do one of these walkthrough videos. I was considering doing one where I go through and show you me struggling to solve the problems, but I don't know how useful that is. Yeah, anyway, ka kite anō. Thank you.